Okay, let's do this. Let's start with Chapter 7. Your Chapter 6 tests are graded. They're put in. I think no one got below an 80. It's pretty good. Oh, yeah, that's right. Good luck. All right, but overall, people did pretty well. So I have that thought because in general, I think parallelograms and quadrilaterals tend to be pretty intuitive. So we're going to keep going with Chapter 7 now. So we're going to kind of move on from parallelograms and quadrilaterals for the time being. And we're going to start talking about ratios and proportions. And you guys have probably seen ratios and proportions for many, many years. So what is a ratio? What is a ratio? What do you mean by overall? Okay, all right, so it's usually contains, usually there's something with the total, all right? So if I asked you guys to give me the ratio of, sweatshirts to students in this room, what would you do? Count the sweatshirts and count the students, right? And it would be however many sweatshirts there are over however many students there are. Good, or a lot of times you see it with, in this bag of M&Ms, what's the ratio of blue to total or blue to brown or whatever it is. So a ratio is just a comparison between two numbers, and the way that they do it is using division or setting it up as a fraction. So ratios can be written three ways. You can either write a ratio, say 3 over 4, 3:4, or 3 to 4. We will always write it like this. Or we'll always write it like a fraction, especially because when you're trying to simplify a ratio, a fraction is usually the simplest way to do that. But if you see it in problems written like this, you can also write that as a fraction. So if you see it written with a colon or you see it written with the word 2, you can always write that as a fraction. The first number goes on top, the second number goes on the bottom. Does the order matter? Yes, the order is very important. Whatever you say first has to go on top or go first in your colon / with the word 2. Okay. The most common ratio that we work with that you did when you worked in algebra and that we're also going to use when we are using it in geometry is the ratio of slope. So what is the slope ratio? Rise over run. Can you use generic words to describe that? What does that mean? What does rise and run mean? Rise means up the y or down the y, right? And then run means, yeah, go ahead. Run means along the x-axis, okay? So if you're moving to the positive side on the x-axis, you're moving to the right. And if you're moving negative, you're moving to the left. Good. So rise over run, if I were going to write the ratio of the slope of line L, where this is line L, how would I do that? What's my slope? If I want to write this as a ratio, what's the slope of this line L? Good. How many units do I go up? 4. And then how many units do I run? 6. Good. So my ratio is 4 over 6. Would we leave it like that? Not usually. Usually you write it how? 2 over 3. What do we call that? Simplifying or reducing. All right. We're simplifying our ratio and making it 2 over 3. So for every 2 that we go up, we have to move 3 over. All right. Remember that rise always goes first, which is why what is the slope formula? All right, that's because it's rise over run. So again, moving on the y-axis and then moving on the x-axis. Hello? Wait, who? Oh, I don't have him right now. It's 8th period. Yeah, it's 8th period. I can figure out where he is. Okay. All right. All right, bye. Okay. Now I have to do so much editing. So annoying. I'm not going to. I'm just going to post it. All right, so when we're writing ratios, this is the ratio of slope because the y means how much you're going up or down, and the x means how much you're going left or right. All right, again, rise has to go first. So you've got to count how many you go up first. Okay, when we're talking about shapes, in this case, first of all, what type of shape is this? Is this a polygon? Yes. Is it regular or irregular? Irregular. Is it convex or concave? Convex, because all your diagonals will be inside it. All right, and it is a quadrilateral. The ratio of the side lengths of this quadrilateral is 2 to 3 to 5 to 7, and its perimeter is 85 feet. So how would you use that to find the length of the longest side? Jennifer?
So the ratio is 2, 3, 5, 7.
Uh-huh.
Add those all up.
Okay.
Will give you 17.
That seems right.
And then you see how much 17 to 85 is, which is times 5.
Okay.
And the longest side in the ratio is 7, so you do 7 times 5.
Okay. So I'm going to back up just a little bit. So 2 plus 3 plus 5 plus 7 gives us 17, which means the perimeter of this one is what? 17. What I'm basically doing is taking this shape, and am I making it bigger or smaller? If the perimeter of the actual shape is 85. I'm enlarging it, right? This is a smaller version of the shape. So I'm taking this shape and I'm enlarging it. But I have to figure out how many times I'm enlarging it. So that means if the perimeter of this model shape, this is our model, all right, if the perimeter of this model shape is 17 and the perimeter of the actual shape is 85, you're asking yourself, okay, how do I get from 17 over to 85? And what do you do to get that? How would you figure that out? Times what? Times whatever. So it's like 17x is equal to 85. And then to figure that out, if you don't just know it off the top of your head, Daisy, divide. So divide by 17, and you end up with x equals 5. So that means to get the whole perimeter, we multiplied by 5. So what would I do to figure out all of the actual sides? Multiply them each by 5. So this side would actually be 10. This one would actually be, and this one, 35. So the longest leg is what? 35. Okay? The other way you could do this is you could say 2x plus 3x plus 5x plus 7x equals 85. And then you add it together and get 17x equals 85, x equals 5. How do you know you need to add them all up? Because they're asking for the perimeter. And perimeter is what? All the sides. Adding up all the sides. So it's like the outside of the figure, right? So again, thinking about perimeter versus area. If you have a farm and you have a garden and it has a fence. Perimeter is the fence. Area is like all the dirt you would need to cover the garden, or if it's nicer, all the grass that's in your garden, all right, or whatever is covering the bottom of your garden. Okay, so cross products property is what you guys have been calling like cross multiplication or the butterfly effect or whatever you want to call it, all right, is proportion, setting up a proportion. So in a proportion, if AB is equal to CD, then B and D are not equal to 0. You can say that AD, which is A times D, is equal to B times C. You guys have been using proportions for years, right? So you guys have seen it in algebra starting with like 3 over 8 equals x over 12. And you would set that up as a cross multiplication problem. So what would you do here to solve this? 8x equals 36 because you do 3 times 12 and 8 times x. And then to finish, you just divide by 8. Perfect. Divide by 8. So x equals 4.5. Yes, 4.5. Okay, so solve these at your seats, A and B. Except when you're looking at B, remember, this is a what? This is a parentheses. This thing is called a what? 2 terms? Starts with a B. Binomial. And when you multiply binomials, remember how you do it. Distribute. Okay, take 2 minutes. See if you can get A and B. Okay, who can come do the first one on the board? Who can come do A? Bianca? All right, guys, eyes up here. We're going to go over B if you did not get it. Can you do it to the right? Yeah. Perfect. All right, so y equals 7. Okay, so for b, we do the exact same thing. You're still cross multiplying, except on one of them, you've got a binomial times a binomial, and here you just have a number times a number, so a monomial times a monomial. What is x squared plus 2 times x squared plus 2? Sorry, x plus 2. So you get x squared. Okay, so x squared plus 2x plus 2x plus 4. And then what's 6 times 24? 144. Okay, now, as soon as you see this x squared, this should be like, if you're looking for like, this is a flashing light that tells you you're going to have to factor. Because you can't just get rid of x squareds like that. So if you want to factor, that means you need to get everything onto one side so that you can get it into a trinomial. So leave the x squared. Combine the two x's, and then what do I do with my 144? I subtract 144 from both sides, and I end up with negative 140. Now that it equals 0, now you can factor it. So again, we talked about factoring a little bit last week, and remember that this is called a quadratic trinomial, and it's typically going to break down into two binomials, where what gives me x squared? X times x, and then I need something that's going to multiply to this, but add up to 4. So what's going to multiply to 140? Just think about it. It ends in a 0, so what do you know goes into it? 10, 20. All right, both of those go into it. Start with easy ones that jump to your head, like 10 times 14. Does that add up to 4? It would be 20 and 7, but is that going to give you 4? No? Okay. So it's going to be 10 and 4, and you need one of them to be positive and one of them to be negative. 14 and 10. Which one needs to be positive? It's got to be 14, because you need the bigger one to be positive so that 4 is positive. All right, we can keep practicing factoring. All right, but this needs to be something that starts to be second nature, because again, what? Because if you do positive 14 would be 14x, and negative 10 would be negative 10x, so 14 minus 10 gives you 4. All right, so then people say like, well, do I need to solve it? Yes, you still need to solve it. So that equals 0, which means that either this part equals 0 or this part equals 0. So to figure out what your answers are, you can do this. X plus 14 equals 0. And then x equals negative 14, or x minus 10 equals 0, plus 10, plus 10, x equals 10. So your two options here are x is negative 14, or x is positive 10.
Wait, so then what's the answer?
But there's two answers. Because if you plug them both in, they work. So if you get 10, you're not wrong, you're just not done. All right? You're not right, exactly. You're not wrong, but you're not fully right.
So opposites can choose whichever?
Well, if you put 10, I'm going to say minus 1/2. You got it. You have to put both, because both of them work, and you're looking for all the things that will work.
Is there ever going to be ones where you get a binomial times the number?
Yes. Like if you had x plus 2 here and 6 here, that's way easier. And here's why. So what Daisy said is, what if you had x plus 2 equal over 6 equals 24 over 8? I don't know if this is going to give us a whole number, but it's going to be easier because when you do this, that just gives you 8x plus 16, and this gives you 144. You don't have an x squared, so you just isolate normally. All right, which would give you 8. Okay, so that one's simpler because it doesn't have the x squared. Again, as soon as you see the x squared, that's what tells you you're going to have to factor. So that's when you need to get it equal to 0 and break it down to this. Now this part down here, the shortcut is, what do you notice about your answers? They're just opposite. So if there's no coefficient in front of x, you don't really have to do this. You just, that's always going to work like that unless you had like a 2x, which I don't think should have. All right, so for basic factoring trinomials that we're going to do, you're pretty much always going to end up just like this. And then it's just opposite. So you don't really need to do this part. So really it's not, like I know it looks like a lot of work, but it's just like to right there. To right here. Because you can say, all right, the opposite, negative 14, positive 10. Those are your two answers. Again, how do you know when you're going to need to do this? When there's an x squared. Okay, so you get it equal to 0 and then break it down. And that's factoring. So if you guys have not done a lot of factoring, again, this is what you need to be really familiar with before you go to Algebra 2. So if this stuff is still like a foreign language and you don't remember it at all or you haven't done it before, make sure you plan on at least coming during some office hours or when we have free time and you guys are working on homework, work on this with me, okay? Because factoring is something that you need to be like really familiar with, especially if you're taking Algebra 2 as a sophomore. They work really quickly on that in Algebra 2 as a sophomore, okay? It's not like scary.
No, it
Just,
confuses me with
yeah.
sometimes with the positive and then when
Yes.
you negative. That's what confuses me.
Yeah, I understand that. The biggest thing I can tell you is that whatever this sign is, your bigger number has to have that sign because you need more 14s to cancel out with the 10s to give you 4. But honestly, practice just makes it easier. Okay. All right, then the last thing is the properties of proportions, which say that this proportion is equivalent to AD times CB, which we already knew because that's just cross multiplication. It's also equivalent to BA and DC. What happened to go from here to here? It just flipped it. That's the same. As long as you flip both of them, same thing here. As long as you flip like A and C became AC and BD became BD, as long as whatever you'd circle here would still be circled together, then they're all the same. So here we would still circle AD, here we'd still circle AD. So as long as they're still in the same circle, they're all equivalent. So if there's an easier way to write it, you can flip it. All right? If you want both of them, like A and D just have to be together and B and C have to be together. It's just for an easier way to write it depending on what your numbers are. Okay, I'm going to give you guys a practice worksheet, but first I would like you to do your exit ticket so you make sure you have that done. So there's templates up there if you need them, and then you're doing all of 1 and 2, and then for 3A, I just want you to do 3A and 3D. Yeah, sorry, you have to do 4.